Hi, everyone. Welcome to Azure User Group Sweden, our weekend session today. Hi, Håkan.
Hi, Yuna. Hi, how are you?
I'm great. Thank you. We have a nice weather today.
Yeah, it seems like
Yes.
it's nice weather everywhere.
Yeah, I can
Then-
see in your your background that it's nice weather there in Norway.
And hello
Yes.
also to you in the audience,
Yes.
wherever you may be. So we're very happy that you took time off to watch this session with us. And I would like to first start with introducing Jonah. So Jonah Anderson is an Azure MVP. She is also a book author, and she's a mentor and also a public speaker and a Microsoft certified trainer. And she
Yes.
works as a consultant for Forefront Consulting.
Yes, thank you, Håkan. And let me introduce you as well to our audience, especially those that are new in our community. So Håkan Silvernagel is manager for AI and big data at Mal's company in Norway. And he's also Microsoft MVP for AI and a community leader here in Azure User Group Sweden and other user groups like the Norwegian.net user group, Oslo AI, and AI 42. So, and he's also a public speaker. So, a lot of great stuff. So, for the community. And before we introduce our speaker today, we have an interesting session. It's about Azure Bicep. We want to show the code of conduct. For our code of conduct, we just want to remind everybody to be nice and friendly, listen with purpose, and be thoughtful, be respectful to others, and be inclusive with your comments and questions. And you can read more about our code of conduct on the links provided on the screen. Yes, and maybe Håkan can share us about our exciting giveaway today.
Yeah, so we're so happy to be able to present here that we have a giveaway. So we have a competition. So the people who are asking the best technical question will stand a chance here to win a Microsoft branded backpack, which is actually really great. I have one myself. And you will also be able to learn more about Bicep. You can find more information on the MS Learn, and you can also get Azure Heroes digital badge if you follow this link here. And we will also post this link on in the chat here. So I think with that said, we will introduce here our speaker, Henry.
Yes.
Hello, good afternoon.
Hello.
Hi, Henry.
Hi. How are you?
Yes.
I am fine. I'm just looking outside and it's a wonderful weather here as well.
Yes.
Excited to be here, but also excited to go out later this afternoon.
Yes.
Yes.
Soon. Yes. Yeah, it's exciting. Yes, so you can go out and have get some sun later. But we're excited to hear about Azure Bicep first before you can go out.
I can imagine. And of course, I will. I can talk about this for 2 hours if you want. So I hope it will be you interrupting me and not, you watching me
Yes.
walk outside too soon.
And
Yes.
also, feel free to post your questions in the chat there, but we should also inform that after the session is finished, we will also have something we called a fika, which is basically like an informal coffee or just a
Mingle.
social mingling on Zoom. So just stay tuned and we will post the link to the Zoom meeting at the end of our session.
Yes, that's right. And we want this session to be as interactive as possible. And if you have questions, feel free to post it in the live chat or discuss it more after the session. All
Yes.
right.
So with that said, we just leave the stage here to you, Henry.
Thank you very much. I see there is one question coming in before we start. Somebody is asking about how to be eligible for the backpack. What I get from you, it will be raffled at the end, depending on who asks the best tech question. So
Yes,
stay with
that's
me.
true.
Is that correct?
Yeah, that's true. So we will raffle it out after the session is finished here.
All right. So stay tuned. And so before we start, if you are wondering who I am, my name is Henry Been. I am a developer and architect from the Netherlands. I actually live on one of the islands of the Netherlands, the most western one of what we call the Waddeneilanden, which is the series of islands that we share with Germany and Denmark, and which is also one of the reasons that it's very sunny outside, because this is one of the most sunniest places in the Netherlands. Now, if you have any questions or reasons you want to reach out to me, comments, maybe criticism, feel free to reach out to me using email, LinkedIn, Twitter, or whatever is there on the screen, and I will repeat that after the session so that you're able to reach me. What I want to try and do with you today is talk about Azure Bicep. Now, before I dive into that, I very quickly want to pull your attention to this book that I've written with two fellow MVPs, Erwin Staal and Eduard Kelholz. It is about Azure Bicep, but also about a lot of other topics in the Azure native infrastructure as code domain. If you really want to learn more about these topics, today I can give you a discount of 35% on the book. It's being sold by Manning. You can go to their website where you can find it, and you can use the code AU35B to get that discount. So thank you for that, Manning. Now, without further ado, I'm going to be trying to teach you in this session how to get started with Bicep with just one goal in mind. And that goal is to take a long look at this beautifully designed Azure portal and then get rid of it. The goal that we're going to try and achieve is to start creating infrastructure, not through the portal, but through our text editor, and then deploying that automatically into Azure. We call that infrastructure as code. And now, before I dive into that infrastructure as code, I just quickly want to sell you on the idea of infrastructure as code and how it can, help you save money before we dive into the tech. The first reason is, if you have been working in IT for a while, you might be familiar with this concept called configuration drift. It is the phenomena where we see that the configuration of different resources in our production environment, let's say virtual machines, are not all the same. If we have 4 production servers, if we look very, very closely, probably all 4 different. For example, one is 2 years old and is running another version of Windows than the one that's 4 years old. And maybe the one that's 3 years old has 2 times the internal memory than the one that's 2 years old. Or maybe someone just went into one of the servers and fixed a production issue there, changing some configuration, and didn't apply the same change on all other 3 servers. We can also have that difference between the test environment and the production environment. Now, a consequence of this is that when we ship changes to our test environment and we validate everything is working, and then progress to our production environment, we might not get the same results as we had in the test environment because there are differences between the environments. Or maybe we deploy to production and we see that one of the servers is not functioning correctly because it has been treated differently in the past. Now, if we start adopting infrastructure as code, we describe the desired state of our infrastructure in files, and we have an engine that constantly applies that state whenever we press the button. This way, we can get rid of the differences between test and production or between different instances in production. That's one of the benefits of infrastructure as code. Another one is that we can really, really quickly create new environments, spin them up, do some testing, and then tear them down. In the past, if you needed a new server to try something, you would first have to request it from the IT department, probably wait 2 weeks. And then once you had it, you would need to install all the servers and base installation and configuration that you need, then install your application, do your testing, and then tear everything down again. With infrastructure as code, we can set up and tear down complete environments in a matter of seconds or minutes. So when you want to do complicated testing, or you want to ensure you have a clean test environment before every test, infrastructure as code can really help you out. And the other thing is repeatability. If we have our infrastructure written as code, we can store it in source control. That means that we can have versions on our infrastructure. And that means that if I roll out version 32 and there is a problem with it, I can very quickly repeat the rollout of version 31. That's another benefit of infrastructure as code. Now, and of course, as we have things as code and we store it in source control, we can apply all the controls that we have developed on sources also on our infrastructure. It is, human readable, thus reviewable. We can have revisions, change management, 4 eyes on the code, and we can have asset owner or product owner sign off before we make the changes into the production environment. And again, if you have been working in IT for some while, you know that this is not just a paper benefit. If you go back to old-fashioned IT where we configure servers manually, research has shown that between 10 and 50% of the changes in production goes differently than the changes done on the test environment. We can completely get rid of that risk using infrastructure as code. All of this means that using infrastructure as code very, very neatly integrates with all the things around DevOps, continuous integration, continuous delivery, and continuous deployment. And I think if you are adopting these practices or looking at it, infrastructure as code is going to be one critical enabler for you, and it's going to, bring you value / money. Now, assuming that you're sold on this idea and you want to apply it in your Azure environment, and you're working with Azure only, and you want to try and stick to native tools, you might have been looking at Azure Resource Manager templates, ARM templates. They're JSON structures that describe infrastructure. They have been around for years, but more recently they were replaced, with Bicep templates. Now, ARM templates are still working. I'm saying replaced because Bicep is just taking over. ARM templates will still work and will continue to work, so they will be side by side on paper. But I think in reality, Bicep will just replace ARM templates from a user's point of view. And the reason for that is actually quite straightforward. This is an example of an ARM template written in JSON. It is used for the creation of a storage account. You can see that on line number 5, where we reference a storage account for creation. Now, the point here is not to understand this JSON completely, but just to take a visual look at how this looks and, have an opinion about how it looks. And that opinion is probably shared with all the developers in the last few years. JSON is very verbose. We need curly braces, commas, quotes, all over the place. It makes it hard to read. It has a very, very strict format, how you encode an object or an array, which means that if you want to put things like function calls into JSON, you will generate very quirky, hard to read JSON. And especially when templates like this began to grow over time. There's a question coming in. I will answer it in a second. When these templates grew over time and became hundreds, maybe thousands of lines, they became very hard, almost impossible to read. So the product group started thinking about how to overcome this problem. And they considered a number of things, and they ended up with the decision to create a own domain-specific language. It's called Bicep, which is a play on, ARM Bicep. It is just a very specific syntax for the very specific problem of describing Azure infrastructure. It is much denser and much easier to read. Just take a look at this. It is the Bicep equivalent of the JSON you just saw before. And I hope you can see that this is visually much more appealing and gives you the confidence that you can much more easily read and understand this. All right. There is a question coming in. The question is, does this mean Bicep is a good replace language from JSON? In the context of describing infrastructure as code for Azure, yes. I think Bicep is going to be the de facto default that we're going to be working in. As a general data storing language, no. I think JSON is going to be predominantly the encoding for data transferring on the internet. But for infrastructure, we're going to replace that with Bicep. I got another question. Why was it named Bicep? Well, ARM, Azure Resource Manager, this is the ARM, had a number of downsides, and they wanted to bring a language that has more power. So what powers your ARM? It's the Bicep, by part at least. So that's the reason for the name Bicep. Originally, it was a code name, but they stick with the name because it really was appreciated by the community. Another question comes in. Can you write Azure policy in Bicep like you can in JSON? Yes, absolutely. Because what you will see in a second is that Bicep and JSON have the same capabilities for the reason of how they work. I'll get to that. And the final question is, are Bicep and Terraform the same? No, they are not. They are two completely different languages. And Terraform is interpreted by the Terraform engine, which has, for example, as advantage that it supports not just Azure, but also all other kinds of targets. The downside is that you need that extra tool, Terraform. If you're just using Azure, Bicep has the advantage that you can stick with Microsoft Azure native tools, so you don't broaden your stack, which I think for a lot of architects is a big concern nowadays, how wide our stacks get. Now, thinking about how Bicep works, and what I do once I've written a Bicep file containing some infrastructure, I can call into a command, which I can download and install from Microsoft, which is called Bicep. Then I add an argument build, and then I specify a file name. What this does, it will take the Bicep file and transpile it into the equivalent ARM template in JSON. In essence, it is a preprocessor or a transpiler, like JavaScript stands to TypeScript. So TypeScript is transpiled into JavaScript, Bicep is transpiled into ARM templates in JSON. And once you have a JSON template, you can do things like AZ group create, and then AZ deployment group create, and just deploy that ARM template as you did before. If you're using a newer version of the CLI, I think 0.22 and up, please don't quote me on that, you don't have to pre-compile anymore. You can directly specify the Bicep file when you're creating the deployment. Now, this is not going to transmit the Bicep file into the Azure environment, to ARM. It is still going to transpile it locally and then submit the generated Bicep file into Azure. Now, if you still want to compile locally, you don't have to install the Bicep compiler or transpiler separately anymore. You can just do AZ Bicep install, it will pull the file, and then you can do AZ Bicep build to build files locally. There are two reasons you might want to do that: to quickly validate if the file is correct before actually trying a deployment, and also maybe you want to get rid of the dependency on the transpiler in your deployment pipelines. You maybe want to transpile the template once into JSON and then reuse that JSON between test and production to get better guarantees about repeatability. All right, now I've been talking, I think, for close to 15 minutes. I hope you're still all awake. I didn't run outside because of the weather. And I reckon you might be looking for a demo. So what I will be trying to do in the next 30 to 45 minutes is to build a complete Azure infrastructure from scratch. And to do that, I'm going to use Bicep. Now, the scenario that let me save you from this animation. Now, the scenario that we're going to be looking into is that I want to run a very simple ASP.NET application on Azure. So I'm going to need an app service that runs on an app service plan. I'm going to need application insights. Maybe I want to do some monitoring and add some configuration. A very to-the-point scenario, I hope. And if you're using the portal, you can probably click this infrastructure together in a few minutes. However, saying that, you think directly, I have to repeat that for acceptance and production, and you don't want to do that. You get fed up with that. So you want to write the infrastructure as code once and then deploy it to multiple environments. So let's get started. I've already opened up Visual Studio Code on my computer, and I'm just going to be starting a new file where I write the Bicep. Now, to help with writing that Bicep, I already installed the extension that can help me with that. The name might not be very surprising. That's also called Bicep. Now, going back to that file, I will save it, and I will call it demo.bicep. And now I can start declaring my infrastructure as code. So let's say I want to start creating a first resource. And that resource is going to be my app service plan. Then I have to write something like this. Wow. Server farms. What you see here is that I first start with declaring that I'm going to need a resource. Then I give that resource a name, which is app service plan. That is the name within this Bicep template. It's not the name in Azure. It is the name that I can use to reference to that service within this template. What I specify next is what we call the resource type, in this case, Microsoft.web/serverforms, followed by @ and then the version of the API that I want to use. And if there's no reason to do something else, I always use the latest one. Now I have to specify the properties for this resource. So I add an equal sign, open curly braces and close curly braces, And now I can start describing what I need from the app service plan. And if I hover the name of the resource, I can actually see that there are some things missing, and the editor is really helping me here. So let's fix that and add a location, which is going to be West Europe in my case. And I need to add a name for the app service plan. Let's call it demo HB 1234563. Free. Guarantee it's unique. And now one of the things that you might know about an app service plan is when you create it, you have to indicate a size, how much performance you want. So in this case, we're going to use a B1, a basic one. And the syntax for writing that is that I provide a SKU. And then within the SKU, I provide a name, where I say B1. This is a full and complete declaration of an app service plan in infrastructure as code. You will see some curly braces here. It's a recommendation to not hard code the location. For now, we're just going to ignore that. So I open up my editor, and hopefully I'm still logged in. So I'm going to create an Azure Resource group. I'm going to call it demo because that's what we're doing here. And it will tell me that I will need to specify a location for that resource group as well. And then, of course, it's also going to tell me that I need to specify -- resource group here in front. And now I've got this new resource group called demo. Now I can say IZ deployment create, and I can say the resource group that I want to deploy to is called demo, and the template file that I want to deploy is called demo.bicep. And then apparently I have to spec AZ deployment, pardon me, group create. And this should start running. Here we go. Now this picks up the bicep file, transpiles it on my local computer, and submits it as a JSON template to Azure to create the infrastructure I just described. So let's open up a portal into the Azure environment, log in, and very quickly switch to the correct tenant, which is my own, and then go to resource groups. And then I have this new resource group demo. Here we can see, if I go to deployments, that my template is submitted, and actually my app service plan has already been created, and it took a legendary 6 seconds. If I go to overview, I see the app service plan as you know it. And from here, I can start, expanding my infrastructure as I need. For example, one of the things that I need to do is to add the actual app service on top of it. So that thing has a type of Microsoft.web/sites. Again, I use the latest version. I add it here. It's going to need a name and a location. So as a location, I use West Europe, and this starts bugging me. As a developer, I've now typed West Europe twice. And that starts to annoy me. So what I want to do is I want to, use that variable only once. So that value only once. So I'm going to create a variable. I'm going to call it location, and I give it a value as West Europe. And then instead of using the actual value here, I'm just going to paste in the name of the variable. Now, this is a good way for not repeating yourself and making sure that if I want to deploy another location, I can change it just in one location and carry on. Now we add a name for the app service. I'm going to do demo HB, add a number again. And then finally, I have to connect this app service to the app service plan to ensure that it runs on top of it. So to do that, you need to add a properties object in which we have to let me very quickly check my notes. Yeah, in which we have to add a server farm ID. And there we have to specify the Azure Resource ID of the app service plan. Now that's a string approximately this long. But instead of writing that directly, I can say app service plan, which references back to the resource I created before, and do .id. This will give me the resource ID of that app service plan. If I now redeploy the template, we will see that next to the app service plan, the app service is being created as well. I see 2 questions coming in. Why can't you run Bicep in the Azure Cloud Shell? So honestly, I never use the Azure Cloud Shell. I always run the terminals on my local computer, but I don't see why you wouldn't be able to use Bicep in the Cloud Shell, honestly. But we can maybe take a look in the after talk where we can try and figure it out together. And the other question is, somebody says that the fonts that I use are too small. I'm just looking at my code editor, and I have 16 lines on the screen. I really can't zoom in any further. Maybe you're referring to the Azure portal. I will zoom in there next time I use it. And there's a question if it's possible to integrate Bicep with Azure DevOps and GitHub Actions. That's absolutely possible. Yes. The best way forward right now is to use the Azure CLI wrapper for running stuff from the deployment pipeline. All right, let's pick up the example a little bit more. As you can see, the deployment of the app service succeeded as well. I now want to talk a little bit about monitoring. And monitoring, I'm going to do using an application insights instance. So I'm creating a new resource. I call it app insights. And then the resource is something with components, Microsoft.insight/components. I add a version, and now I can start adding properties here as well. Let's be a little bit cheeky and copy and paste the location and the name from my app service. And there are 2 more properties that I need to add to an application insight. First of all, I have to specify the kind, which is web. And another thing I have to do is, again, add a properties object in which I say the application type, again, is web. At this point, you might be wondering, how does he know all these properties top of mind? Well, honestly, I don't. I have notes. They really help. But you don't, and especially not for all the stuff that's out there. So what you can do is you can go into your browser and Google for the ARM template reference. Simple as that. ARM template reference. If you Google for that, at least in my occurrence, always the first hit is going to be this page. And what you can do here is you can find any resource you need. Let's say, for example, I want to do something with SQL. I want to create a server. I can find it here, SQL and then servers. And here I get an example which shows me all the properties that I can use when describing that resource. And below is a complete breakdown of every property, what it does, and the type that it has. And if you're looking for examples, they're even down below here as well. So you can find, I don't know, what do we have here? A Django app with a SQL database. I haven't done anything with Django, like ever, but apparently there's an example. And you can see for just SQL database, there are many, many examples around. All right. Now I can create my application insights like this, but that leaves me with an application insights that's not connected to my app service. And if you're running services in Azure, you probably know that I need to get the instrumentation key out of my application insights and copy it into the configuration of my app service. Now we can do that using a specific resource type which is called config. So I will create a new resource. I will name it app service config, and it is going to be of type config. Of course, I will use the latest version. And what you might notice here is that I'm nesting this within the app service. And that's because the configuration is what we call a sub-resource. And the full resource type is Microsoft.web/sites/config. Now I've added this configuration and it's telling me that it needs a name. I know, because the type of configuration that I want to add is app settings. This is one of the types of configuration that you can set on an app service, but app settings, I think, is the one that we're all familiar with. Now, what I can do here is I can add a properties array, and here I can specify key values that contain the configuration that's going to be inserted in my app service plan. Now, the one thing that I will need is application insights _instrumentation. instrumentation key. And then the value needs to be the instrumentation key that I can get out of the application insights resource. But what I can also do, I can also reference app insights within my template, call into it, and then go to its properties, and then find its instrumentation key. So what this is doing now, it is once application insight is created, it's going to update the configuration of my app service automatically with the correct key. I'm not storing it anywhere. It's not in the key vault. I'm passing it on directly. If you feel this is not secure enough, you can still store it in a key vault and refer it from the app service configuration, but it's not what we're going to be doing today. Now let's quickly redeploy this, see if everything is working while I go over some questions. It's still going on about the Azure Cloud Shell, which I can't help with for now. I'm sorry. All right, that's still Bicep. All right. Now, while this is running, I want to show you a few variations of how you can work with nested resources. As you can see here, I've nested one resource in another. That's not a thing that everybody likes. So what you can do instead is you can also take it and just put it down here below and update the type to be the full type. However, there is a rule that says that the name should contain the number of slashes in the type -1. In other words, I need to put this name here as well, because this is a nested resource, and this way ARM knows in which resource it should be nested. I kind of don't want to repeat the name here, so I'm going to use another language feature, which is called string interpolation. I go to my app service, and then I fetch its name. Another thing, if I don't want to repeat this name, which is new and specific to Bicep and doesn't work in ARM templates in JSON, I can also use the parent property, parent, and then reference to the app service. And that way, the transpiler can automatically derive the correct full name. Now, depending on how you want to structure your files, you can either use this syntax or nest resources within one another. Now, again, my creation succeeds, which is wonderful, but I'm going to run into a problem when I want to take this infrastructure into a real environment. And that is that I cannot deploy this into a test environment and into a production environment because the names of certain resources in Azure have to be unique. So what I kind of want to do is I want to postfix all the names either with TST or PRD for test production. Now, what I can do is, because it not just supports variables, but also parameters, I can add a parameter. And I can call it, let's say, environment name. And it should be of type string. Now, I can go into the names of my resources, use string interpolation, and then reference that environment name here. And I can append that to the names of all my resources, except for the settings, because this app settings is a mandatory name. Now, I don't want to, have everybody put in things like YOLO or whatever. So I'm going to add what we call an annotation. And there are many annotations. For example, you can say a min length, max length, even a description. But I'm going to use allowed. And allowed takes an array of values that are allowed values. So TST and PRD, I'm going to allow. If I now redeploy my template once more, it is going to say, hey, this template takes a parameter and you didn't specify a value yet. So please choose one, either TST or Pro. I'm going to use test. And this is going to redeploy my resources within Azure, but now with different names. So if we go into my Azure environment and refresh this, we see the 3 resources we created at the start, and we will probably see 3 new ones with had the same name, but TST at the end. Now, at this point, often somebody asks, can we also use templates like this for removing resources we don't need anymore? And yes, that's possible. ARM templates support what we call the deployment mode. And the deployment mode can either be incremental or complete. Incremental means that we're only going to add resources into Azure that are in our template, but not in Azure. Or we are going to update the properties of resources that are both in our template and in Azure, and where there is a difference in the properties. If we now switch the deployment mode to complete, we will get all that behavior, but what it will also do is that it will look into Azure and it finds resources that are in Azure, but not in the template, and it will remove those. So if I go into the Azure portal and I refresh here, let's hope I deliver. And here we go. We have 6 resources now, with and without test. Now, if I now go back and I deploy one more time, and I do -- mode, and I say complete, it will rerun the template in a complete deployment mode. I go for test, and this will also, it will check the existing resources, update the configuration or the properties if needed, which it isn't because I didn't change anything. And it will remove those resources that don't have TST as a postfix. This is just one of the tricks that come with infrastructure as code. Now, this is, of course, a double-edged sword, right? If you remove something from your template by accident and then redeploy it in complete mode, stuff is really going to be gone. You can use logs to prevent it, but think about the consequences before you use this. Now, what we have seen so far are a number of constructs of the language. We have seen how you can create resources. We've seen how you can create parameters and variables. There's one more thing that I want to show you. Well, actually, there are a few more, but for keywords in this file is output. As we can use parameters to pass a value into a file before we start deploying it, we can also use the output keyword to generate a value that we provide to the calling process, for example, to chain something else. If we're talking about environment creation, and I think, for example, about a GitHub action or a DevOps pipeline, I can first deploy my infrastructure as code, which will generate a new name or URL for my app service. And then I can return that name of the app service so that I can chain the deployment of the code to that correct app service after it. So I can generate new environments with new names all the time and reuse the values that come out of it. So let's say that I want to output my app service name, which is going to be a string, and the value is going to be derived from my apps, not my app insights, but my app service, and then its name. But if you want to, I don't know, output, for example, the application insights key, application insights instrumentation key, which is also a string, you can get it from the app insights.properties.instrumentation key. Instrumentation key. Now, it's another thing I would recommend, even though it's not masked in the portal, I would recommend treating the instrumentation key as a secret as much as possible. So let's remove that. And if I now redeploy this one more time, we will see that once it completes, it will return that app service name to the command line for pickup in the chaining process. And if we now go back into the Azure portal, we will see that the number of resources has been reduced from 6 back to 3. And the ones without the TST postfix have been removed. All right, time for some questions. The question is, does Bicep support managing all Azure resources, such as an Azure Active Directory or Active Directory B2C instance? That's a good question. A mistake a number of people still make is the following. If we think about how, let's say, an Azure tenant is organized, we have an Azure Active Directory at the top, and then, for example, Azure DevOps instances, and Azure subscriptions, and I don't know, Office 365 stuff. They're all, below that Active Directory, because this is the authentication provider for all these services. Now, if you go into the Azure portal, it feels a little bit the other way around, because in the Azure portal, you see AAD stuff. And you can manage AAD stuff through the Azure portal. However, Azure is below the AAD, and the consequence of this is also that ARM, which is the API in front of Azure, where you send your Bicep templates, cannot right now manage Azure Active Directory. For B2C, I have to come up short on the answer because I know B2C is a specific type of resource. I just don't know. But I can look it up during the Zoom call later for you. However, the product team has said that they are looking to extend Bicep to support other resources than just Azure resources. And Active Directory is the first one they're going to be looking at. A question comes in if there are any sample templates for Bicep. Yes, absolutely. If I go back into, let's say, Google again, and I search for Bicep template GitHub examples, I hopefully find it. The first one I find is /Azure/Bicep, which is a description of actually the language introduction by Brendan Burns, and a lot of stuff that I know has been written by the product group. So this is about the language and how it's built up. So it's more of a reference. If another temp repository, this is the one that I was looking for. It's called /Azure/Azure-quickstart-templates. This contains hundreds of examples of ARM templates and Bicep templates for all kinds of situations. And if you go back to the reference that we talked about before, and you click any of the examples here, it will also take you to the same repository and then to the specific examples for that type of resource. Any questions? No, I think that answers all the questions. All right. So we've basically gone over all the language constructs that I can use within a file. Now, one of the problems that I said with ARM templates in JSON was that the files grew very long and became hard to read. Now, there was a way in Azure to take parts of a template out and store it in a separate file and then reference it from another template. But to do that, you had to take the file, put it on an HTTPS location, and reference it through the URL. Or you could nest templates within each other, but then they had to be in the same file again. With Bicep, it is possible to take another Bicep file and reference it from another Bicep file. We then call this often an orchestrating template. And that means that I can now spread my resources over different files and put everything together in one template using a modular approach, which can help me keep my code organized. And I want to show that to you as well. Now, I'm going to be cheating a little bit because I've already prepared another Bicep file, which is called metric_module.bicep, which contains a resource which describes an Azure alert that should go off whenever there is a certain metric that goes above a certain threshold. Now, this is a valid Bicep file in its own. There is nothing special about it. It has parameters and a resource. And I want to use that resource. So to use it, I am going to go at the bottom of my file, and instead of declaring a resource, I'm going to be declaring the use of a module. I need it as well to give it a name, so let's give it alert rule deployment, and then I can reference a file. So let's say metric module, and again I use an equal sign in curly braces for specifying the properties. Now, what I'm doing here, if you really look into how ARM is working, I am starting another deployment from the deployment of this template. And I have to give a name to that deployment. So let's call it alert rule template deployment. And another thing that I need to provide are the parameters for this module. And as you can see, it has 4 of them. So I open up an object, and now I'm pressing Control Space, and I will get hints about the values that I need to provide. So I need the application insights ID, apparently. So I use app insights.id. It needs a metric identifier. So let me very quickly take a peek at what that should be. It should be a requests field. It needs a metric name, so that's a display name. So let's call that field requests. And finally, it needs a threshold. And of course, I want to know as soon as it's greater than 0. I can now deploy this as well. And let me use incremental mode again to speed this up a little bit. I'm still deploying to test. What this will do on my local computer when transpiling, it will pull the contents of this metric module into the full template. So if I were just to transpile this, it would generate one, very hard to comprehend, JSON file with all the resources. But the code that I work on is spread over multiple files. If we now look in how Azure deploys this, if I go to deployments, what I see here is that I now get multiple deployments. I get my demo deployment, and this contains the deployment of the resources in my template, the TST thingies, and the app settings, but it also contains the deployment of another deployment. And this deployment will contain my alert rule, as you can see right here. This might be a little bit confusing at first, but this is a way how a very large composing templates can cascade into a number of separate deployments. Now, to wrap this demo up, I do want to show you two more things that the language can do. And the first one is that I can say if. I can add a condition to the deployment of a resource. For example, I don't want to get called out of bed by alerts on my test environment. So maybe I only want to deploy this when I am targeting with a parameter value of PRD for my environment name. This is a thing that I can add to resources. So that's a conditional. Another thing that you can do is a loop. So the thing that I want to show here is that, for example, I can write the following syntax. Let's remove the conditional and say, for each entry in a list, I want to deploy the following metric. And then I have to put a closing square bracket here as well. Now, if you're familiar with Python, this might look a lot like Python comprehensions. And I think that was actually also the inspiration for this syntax. Now I'm going to create an instance of my alert rule for every entry in a variable or parameter called list. It's not there yet, so let's create it and say variable list is an array, and in it I'm going to specify objects. Actually, I'm going to do 2 because I want to create not just 1 but 2 alerts, and I don't want to repeat the whole block when there are no differences. So let's say that the only things that I want to vary are the metric identifier and the metric name. The first one is going to be the same. And for the second one, I want to alert on field dependencies. Now what I can do here is, instead of specifying the value directly, I can say entry dot metric identifier. And here I can say entry dot metric name. If I now redeploy the template, the module will be deployed 2 times. And I'm actually going to abort this because it will give an error. And I will get 2 alert rules. Of course, what I do need to do as well is that I need to make the name of the deployment of that alert rule unique. So let's just add the entry.metric name to it as well. So now we should see a successful deployment first of my demo template, which then triggers 2 times the deployment of an alert rule, and we should that play out successfully. And I think with that I have shown you all of the important language features, and hopefully I have given you enough, basics to start using Bicep in your own projects. Now, while we wait for this to run, feel free to hit me with any of your questions while I refresh the portal. And what we see now is that it's going to start the deployment of my demo template. Oh no, there are errors. And the provided deployment name, alert rule, template deployment field dependencies has invalid characters. The name can only be a letter, digit, dash, or underscore. Did I put in a... okay, let's fix it like this. Deployment name, alert rule, failed requests. And here's a field depths. And here I will pick the deployment name. Let's hit it again. Apparently I didn't sacrifice enough to the demo gods today, but hopefully this will work out better. So going in here again, I now see the deployment of my demo template, still deploying. I already see successful deployments of my 2 alert rules, which I find very, very hard to believe, but they just really completed sub-second apparently. And now my demo template completed as well. And if I go into my overview, show hidden types, I see all the resources that I specified in my ARM template. I think that are all the things that I wanted to show you. So to quickly recap what you have seen, we have seen a bit of syntax. We can use variables. Var name is value. Parameters, param name type is optionally a default value. You also seen that we can use annotations on these to mark things as secure or provide, for example, valid values that a user can choose from. You have seen outputs, how you can deliver values back to the one or that is calling the deployment of the template. You have seen the use. Wow, you haven't seen the use of functions. Let me show you functions. One of the things, for example, that I can do is instead of providing the location of this template directly, I can call into a function called resource group, which will give me information about the resource group that I'm deploying to. For example, its name, tags, properties. I don't know what's in properties for a resource group. Oh, the provisioning state. That's fantastic. But I can also access its location. So if I now do this, all the resources will automatically default to the location of the resource group. If I deploy this again, it will still work because everything is West Europe. If you try to change the location of a resource, the deployment will fail. And there are many functions like this available. For example, there is one that's called subscription, which will give you the display name and the ID of the subscription, and also the ID of the AID tenant that the subscription belongs to. There's a function called tenant that gives you information about the AID tenant. There are many, many more. And if you search on Google for ARM template functions, you will get the full list of all the functions that are available. All right. Apologies for that, but now you have seen functions. What you have also seen is how I can use the symbolic name of a resource within a template to refer to resources defined in the template without having to build their full resource ID or to use their actual name in Azure. And finally, you have seen something about control flow and the reuse of modules, of templates as modules. So the module keyword is how you do that. And you have seen how you can use loops or conditionals to deploy the same resource multiple times or deploy or not deploy the resource based on the outcome of some kind of evaluation. Now, this is a bit of a two-edged sword as well. If I write infrastructure as code, I want the outcomes of the deployment of a template to be as predictable as possible, because I want to do it in test, and then I want to have a very good feeling that I'm going to get the same results when I do it in production. If I have a very lengthy template full of conditionals and for loops over arrays that get passed in as a parameter that's different between test and production, the guarantees that my tests in the test environment provide about how things will perform in the production environment will decrease. So I would use this with care and only when there are no other solutions. For example, if you want to deploy alert rules only in production and not in test, you could consider putting them in a separate template. So instead of having conditionals all over the place, there's one template that you deploy in test and production, and there is one template that you only deploy in production. or maybe in pre-production and production. That being said, I really want to encourage you, please do try this at home. Get your hands a little bit dirty. I feel confident that everybody who plays for a couple of hours with Bicep should be able to start using this in real projects in the real world. Comparing it to ARM templates, it is a huge step up. And I want to encourage you all to start and try using it. Now, for those interested and didn't have the opportunity to ask questions yet, feel free to ask them right now. Let me see if there are any questions.
Yes. So thank you so much, Henry. We actually have a couple of questions here that we want to present here. So one of them is this question from Gopal. So you were mentioning a little bit about Terraform, but I think it's worth reminding people here. So his question is, how does Bicep compare to Terraform and Pulumi, etc.?
Pulumi is different from a lot of other languages because, as they put it, it's actually infrastructure really as code instead of as JSON or Bicep or Terraform. You write it in, I think, TypeScript, C#, and they probably support more languages by now. But you write C# code that builds an object structure which describes what your infrastructure should look like, and then you pass that set of POCOs POCOs on to the Pulumi engine, and that will create the infrastructure for you. So it's real C#. That means that you can run it, you can debug it, and you can write unit tests for it in a way that you might already know. That's Pulumi. Terraform is a domain-specific language, just like Bicep. Now, Bicep has a transpiler provided by Microsoft by the same team as that's building ARM. So if you are using only Azure, it has the added benefit of that you don't need any tools outside of your already existing Azure stack. Terraform has the advantage that it can target not just Azure, but also AWS. But also, for example, if you have a DNS provider, it might be that there is a Terraform module for configuring DNS from infrastructure as code. So it can target a wider range of systems. However, as it is not part of the native Azure stuff, it might be that some of the newer things that are in Azure Resource Manager are not yet provided in Terraform. This especially used to be the case in the past, but I think this is improving over time. But I'm not a Terraform user. I only do Azure. But I think that helps hopefully position the three different tools. And if that doesn't answer the question, please let me know.
Yes. We also have another question here from Doctor. I think it's Doctor. Is Bicep meant for GitHub? Doctor Who. Is Bicep meant for GitHub only, or it can be used in Azure DevOps?
It is absolutely not restricted to GitHub or GitHub Actions. You can run Bicep from Azure DevOps pipelines. I'm doing that myself. Actually, I think all my customer projects still have been using Azure DevOps, not GitHub yet. But you don't need either of them as well, because you saw I ran it from my local computer. Not necessarily a practice I would recommend for deploying to production, but it is possible. But if you're using GitLab or a comparable product, you should still be able to use all these tools. But maybe you have to script them instead of having conveniently wrap that into tasks for DevOps or GitHub Actions. I know there is a GitHub Action available for Bicep. I know there has been a lot of debate about Azure DevOps tasks. I have to admit, I'm not certain if there is one released by now.
Okay, good. And then we also have another question here from Azara, who says, do you have any converter for JSON to Bicep template conversion?
Yeah, that's a good question. Let me give you two tricks when you don't want to start writing Bicep from scratch. The first one is if you go into the portal and you go to any resource, let's say this app service plan, and fun story, I'm still Henry, and I go into this resource and then I wait for it to load. Yes. At the top right, I can click JSON view. And this is available for many, many resources in the Azure portal. What this will give me is the JSON equivalent of that resource. Now, this has a downside. It also includes all the defaults. So if you want to, and some resources have a lot of properties, and I would recommend not specifying the defaults because it keeps your templates readable. So that's about reverse engineering. You can also export a whole resource group at a time, but we're touching upon time, so I'm going to be very quick. And the other thing that you can do is, I told you about AZ Bicep build, right? Where you can provide a file using -- file, and this will take my demo.bicep file. It should take my, no space, my demo.bicep file, and it will generate a file called demo.json, which is here. Now, comparing those two files, let me first point out that this one is only 66 lines with a lot of new lines. And this one is a lot longer. And as you can see by scrolling through it, this is already practically becoming unreadable, while this is still very, very small. Now, to answer the question, you can also do AZ Bicep. I think it's called decompile. Yeah, there we go. And I specify a file, in this case demo.json. And this will decompile a JSON file into an equivalent Bicep file. Now, of course, it's like decompiling always, not perfectly readable, but it is a very, very good starting point if you want to convert your existing JSON templates into Bicep templates. Sorry about just jumping back onto the screen there, Jonah.
Yes, it's I'm a developer as well, so I like seeing code. Yes,
Cool.
that's great. Do we have more questions? Actually, we have a lot of interaction today. Let's see.
We have one comment at least
Yeah.
here from
Yes.
Gopal, who says, "Thank you for a very nice session here." And
My pleasure.
Yes.
Also, thank you to Sebastian, who was actually commenting on what you actually showed here on how you can decompile this template. I think that's
Yes,
it.
we also have someone here who says, let's see, just feedback. I want to be a DevOps engineer at Microsoft, but I don't know where to start. Do you have any advice for as a DevOps expert, Henry?
I would
him?
rarely call myself ever an expert. A specialist, I call myself. I think expert hints that you think you know everything, and as soon as you stop learning, you're going to be obsolete very quickly in our line of business. So at Microsoft or with Microsoft technology, I think that's a difference. So let me start with Microsoft technology. I think getting your hands dirty is my best recommendation. So that I mean by practice and try things out. Even if you're already working at a company that has a very large solution that is kind of sluggish and slow to work with, take the time to go into Visual Studio or Visual Studio Code, file, new, try something for 30 minutes. If I go back to my first years, how I learned was not thinking about, for example, dependency injection in that massive monolith, but going, file, new project, install a DI container, and fiddling with the different lifetimes. That's how I learned, and I highly recommend that. And I've also had the privilege of a formal education in computer science. If you get the opportunity, I am very grateful of my education. It's not everything, it's just the basis. But if you get the opportunity, I would highly recommend that as well. Now, for applying at Microsoft, I honestly have no idea because I don't work there either. So I can't help there, sure. But we can talk maybe a little bit more in the Zoom call. Can I be very bold to take this 30 seconds as
Yes.
we're running out of time to thank you for your invitation. It was very wonderful to be here. Thank you.
Yes, thank you so much
Yeah,
for
thank you.
the great presentation. We have a great feedback from hello from Wayne from South Africa, and also Doctor said very nice and informative session. Yes. So yes. So we're gonna have an after session fika or digital fika later, and you get a chance to ask more questions with Henry or mingle with us with other members in the community. So we will be sharing the not that one. I'm sorry, the link to the chat if you want to join us later.
And also, if you have a mobile phone, you can also scan this QR code.
Yes. Yes. So, yeah. All right. Okay.
Yes.
Yes. So, thank you so much, Henry.
And
yeah.
Thank you so much, Henry, for a very informative session. And also for those of you who are wondering about the backpack, me and Jonah will select the winner for the best technical question, and then we will announce it on Twitter. So stay alerted to our Twitter feed, and then you will know who was the winner.
Yes. Yes. Thank you so much. So I think it's time to say goodbye. Yes. Let's see. All right. Have a great weekend, everyone.
Yes. Bye-bye.
Bye-bye.